Hi guys, my name's Catherine. I'm one of the tutors here at Chegg. I typically tutor science, math, English, and Spanish. And today we are going to be talking about atoms, which are a science topic, obviously. So one of my favorite corny science jokes is never trust an atom. They make up everything. And the reason for this is because atoms make up all of the stuff that you can think of. They make up you, they make up rocks, paper, water, they make up all gases, just everything that counts as matter is made up of atoms, whether it's alive or dead. And atoms are therefore considered the main building block of life, because even though there are things that atoms are made up of, you'll never find these things by themselves. You can find just one atom, but you can't find just one of the components of an atom by itself. So the three main components of an atom are the proton, the neutron, and the electron. Protons and neutrons sit together in what's called the nucleus, and then the electrons are in this big cloud all the way around it. And when I say big, it's massive. If you were to have a nucleus that was the size of a pea, the electron cloud would have to be as big as a football stadium. But we're not going to draw it that big for this. We're definitely not drawing it to scale because there'd be no way to fit everything in here. So let's choose an atom. So we have here a periodic table. This is a way that scientists use to organize all of the atoms. Each specific combination of protons, neutrons, and electrons gives you a different element based on how many electrons it has and how many protons and neutrons. We arrange it into rows and columns. So long as something is not radioactive, it will have the same number of protons and neutrons, and it has to have the right number of electrons to balance that so long as it's not an ion. An ion is just an atom that is charged, that isn't balanced. So let's choose this one right here. So Na is an abbreviation for sodium. Don't ask me why, just is. And we see here that it has the atomic number of 11. And if we were to count, some of it is off screen, but if we were to start, it's the 11th atom, or the 11th element. So from that, we know that sodium has 11 protons and 11 neutrons when it's not radioactive, and 11 electrons when it's not charged. So here, let's put the 11 protons and the 11 neutrons. And the reason that we need these electrons is because right here, so let's talk a little bit about charge for a second. Protons are positively charged, P for positive. Neutrons are negatively charged. They don't have any charge at all, N for negative, and neutrally charged. Yeah, I think I just said N for negative. That's not true. It's N for neutral. Neutrons are neutrally charged, and electrons are negative. If we were to just have protons and neutrons with no electrons, we would have a positive charge here, right? Because 11 positive plus 11 nothing equals positive 11. So we need a negative 11 to balance that out. So we'll need 11 electrons. So I'm going to draw them in blue. In the first, first off, electrons are in typically what's called an electron cloud. So you can't see an electron, but it would look, if you were to try to follow an electron's path around a nucleus, it would look like that. It would just be absolutely crazy. It'd be all over the place. Wouldn't know what to do with itself, that sort of thing. Or at least that's what it looks like. But the reality of the situation is that electrons actually fall into specific energy levels. And we're going to draw those levels as concentric circles around the nucleus so that we can see them better. So the very first circle, the lowest energy level, can only hold 2 electrons. So we're going to draw those right here, 1 and 2. But remember, we need 11 total, so 11 minus 2 is 9 more. So we draw a circle here just to mark the difference. Once again, this is not how that would actually be. The next level can hold up to 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And the reason that it can hold 8 while the first one has 2 has to do with what's called orbitals. Orbitals are the way the atoms are able to hold onto their electrons so that they don't lose them. And this one that's close is smaller because it's closer, and so it can only hold 2. And this one that's out here can hold up to 8. All right, so we have 2 and we have 8, which is a total of 10. But we still need one more, right? Because we should have 11 electrons in order to have a balanced sodium atom. So just one in this outer ring right here. And so that is a sodium atom. As you might have noticed, this electron that's all by itself looks like it's not at all attached to this nucleus, right? Looks like it could go flying off at any second. And that's why we have a lot of things like sodium chloride. Because if you look over here, well, it's right, you can kind of, here, I'll move me over. And you can kind of see here in the corner, you can see Cl right there. Chlorine, that's what Cl is for, is made of 17 neutrons and 17 protons and 17 electrons. So let's actually make this into a chlorine, because I can show you something pretty cool. It's also worth noting that this level out here, the one that only has 1 for the sodium, it can also hold 8 electrons. So instead of getting 11 each, what if we're trying to get 17 each? That was the number, right? 17. Okay. So 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. And then in our outermost row, we have 1, 2, 3, 4, 5, 6, 7. So while this chlorine that I've drawn here is missing 1 to complete its outer ring, and the sodium had 1 extra that if it got rid of it would have full rings, often the sodium will donate an electron to a chlorine, which is how we get table salt. And so those are the basics of atoms. I hope that you enjoyed this lesson, and if you have any questions, you can feel free to contact me on Chegg.